Hey yo, it's your boy Algebra coming to you live and direct from the studio, aka my living room. Just want to go over something with you real quick regarding the rational root theorem. This is the part 3 video. So if you have not watched part 1, you're okay because I didn't actually make one. We talked about synthetic division in the first video. In the second video, I did talk about the rational root theorem, tried to explain it a little bit, but I feel like there's still probably a little bit of a disconnect, / some people decided that they just didn't watch the video. So this is the third attempt at making sure that we're all clear on the rational root theorem. I'm going to be taking a polynomial and breaking it all the way down into all of its factored parts, using synthetic division, possibly a little bit of factoring towards the end of it, and then also talking through a little bit about graphing. This video in total, I'm about a minute in right now. It's going to end at about 8 minutes. At least that's my goal for right now. The problem that we're going to be doing this time is f of x equals x to the 4th minus x to the 3rd minus 11x squared plus 9x plus 18. Alright, so particularly this time of night, it's about 10:22. So my voice may be a little bit raspier than normal. No, I'm not getting sick, but I am a little bit tired. That was deep. Y'all might catch on to that in a little bit. I know my boy Jacob Lacey over there, all his voice cracking and everything. I know he feels me. Him and all his sons. So here I go. I need to know which numbers to plug in first, and to do that I need to be looking at two things. First, the leading coefficient. That would be my denominator. It could be positive or negative 1 on the bottom. The other numbers that I'm looking at possibly plugging in come from this 18. Factors of 18 include 1, 2, 3, 6, 9, or 18. Total, that gives me a grand total of 12 different numbers that I could possibly choose to plug into my synthetic division problem. These are the choices. What do you want to start with? Personally, I'm feeling a little bit negative, but when I feel negative, I want to make sure that it's a small amount. So, I'm going to start off with a negative 1. I would say that negative 1 is a number that I will continuously use. Hint, hint, wink, wink, nudge, 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 wiggle, wiggle. And so you should probably start your synthetic division off with negative 1 the majority of the time. Negative 1 it shall be. Where do the rest of the synthetic division comes from? It comes from the coefficients in the problem. 1, negative 1, negative 11, 9, 18. Line, answer box, is this going to work? So I'll go ahead and go through the process. Straight down for the first number, multiply to get it back in. Straight down with addition, multiply times negative 1 to get it back in. Adding straight down, multiply times negative 1 to get it back in, and then add straight down one last time, multiply it, and then you get a 0. So because that worked, it tells us for a fact that this is one of the zeros of my equation. What does it mean to be a 0? It means that your line is going to be crossing the x-axis at that particular point. When I get to the point negative 1, 0, it's going to be changing. Maybe it just taps that axis, but it has a possibility of going straight through. We'll talk about that as I finish dealing with multiplicity. So we have the option now. We can continue through the synthetic division process using the negative 1, or we can switch numbers. Why not try negative 1 again? It might work twice. If it does, that's going to tell us that we have a multiplicity. And that multiplicity could be 2, it might be 3. Multiplicity could be saying that I'm using the same point all 4 times. It's not going to work out that way this time, but we might as well check it. 1, negative 1. negative 3, positive 3. Negative 6, positive 6, 24. That didn't work. So one of the things that you guys are going to run into is, how do I check a different number? I don't want you to go all the way back to the beginning. I want you to take that level that we just tried and use it again. So new synthetic division. I'm feeling, a little bit adventurous. I'm going to try a positive 2. I'm getting good vibes from that. But again, I don't want to start at the very beginning. I want to start from this level right here, trying a different number. 1, negative 2, negative 9, and 18 were my coefficients. Is the synthetic division going to work out? Sending it down. 1. Multiply times 2 to get it back in there. 0. Interesting. Multiply that times 2 to get it back in there. Bring it down, negative 9. Times 2 to send it back in. Oh my God, Mr. Somerville, you must be a wizard or something, because you made it work out perfectly this time. So what do I want to do now? I have a trinomial down here at the bottom. That's 3 terms. That is an x squared minus 9. Sounds factorable to me. Whenever you get down to 3 terms, you should leave the synthetic division process and go into factoring. Factor in this problem. X squared minus 9 equals 0. You know the answer already. X plus 3, x minus 3. X could be negative 3. X could be positive 3. So let me go back and do something real quick. I want to remind you of the fact that this was the 4th degree. That means we should have 4 x-intercepts. I've got a positive 3, a negative 3. I have a positive 2 and a negative 1 as well. These are all of my x-intercepts. These are all the zeros to this polynomial. And so now that I have identified each one of these different pieces, I would be in a situation where I'm ready to graph. The next thing that we do, we're going to be going into your study guide packet. No, you're not going to finish this, but the process that I've just outlined for you is going to be directly applicable to that. I said I was going to be done in 8 minutes. I'm done, but I do want to go through that packet with you. So go ahead, go to your packet now, and then we'll be good to go after I finish that first problem. Here's my first problem. It says, what are all the possible rational roots or zeros for this function? Remember, the bottom comes from here. The bottom might be a 1. It might be a 3. The top comes from over here. The top could be a 1, possibly a 2. So all of the possible rational roots for this include positive or negative 1, positive or negative 2, positive or negative 1/3, or positive or negative 2/3. So remember, this is your top. The bottom came from the leading coefficient. So it says find all zeros of the function. I've never done a synthetic division problem with you that involved fractions. So I'm feeling like that's where I want to start this time. Find all the zeros of the function. I'm going to start feeling a little frisky again. Small and negative. Negative 1/3 is what I'm going to choose. Now, of course, you do not have to start with a fraction. You do not have to start with a negative. You could go with positive 1. You could go with negative 1 like we did on the last problem. That is always your choice. I made the problem. I know how it's going to end up. That's why I chose this one. 3, 13, 19, 11, 2. Answer line. Hopefully this ends up being a 0. Let the process begin. 3 times negative 1/3 minus 1. Oh, snaps. That worked out perfectly. So I'm thinking now, okay, so negative 1/3 worked. Could I plug in something different? Or should I try negative 1/3 again? Gut feeling says it worked once. It could work again, but more than likely, probably not. So I'm going to try a different number. I'm going to go -1. So as I plug in this -1, it is my new critical value, vocabulary word right there. And with this new critical value, I follow the same process. Oh my God, Mr. Somerville, it worked again. Are you a wizard or something? I might actually be a wizard. But the goal of the problem was to get it down to a trinomial so that you could solve it. This part down here, 3 terms, says that this is really 3x squared plus 9x plus 6, which is in fact a factorable problem. If it wasn't factorable, that wouldn't change anything. It would just mean you need to do the quadratic formula. Still have to get your 2 answers for it. So I'm going to factor this. I'm taking the 3 out first. Oh, I forgot about the GCF, Mr. Somerville. That's really convenient. Yes, it is. Factor it like a normal trinomial now. And I now have an extra set of zeros. X equals -2. X equals -1. That gives me my 4 zeros for this problem. -1/3, -1, -1 again, and then -2. Suppose I wanted to see what the factored form would look like. If I wanted to talk about factored form, I would just be taking each one of these and putting them back into parentheses. I could have said at the very beginning of this thing, f of x equals 3 times x plus 1/3, x plus 1 squared, and then x plus 2. Now, the question has come up a few times over the past couple of days. Why are these pluses now when all the answers were actually negative numbers? Remember when we talked about transformations and all those different graphs I made you memorize? When things change inside the parentheses, you have to use the opposite. So if you started off with a number and you put it back in the parentheses, you need to use the opposite. Let us go graph. It says, what is the y-intercept? Well, the y-intercept comes from when you plug in x is 0. Plugging it back in right there, you can tell for a fact right away that should be 2. It says, in which direction does the graph finish? That means you're supposed to be looking at the leading coefficient. Is it positive or negative? It's positive, therefore the graph finishes up. Where does the direction of the graph's beginning? You're looking at the degree. If it's even, then it starts the same way that it ends. If it's odd, it will be pointing the opposite direction. This is definitely an even degree, so we're looking up. And it says, what are the x-intercepts of this function? That's all the work that you just did. It was the -1/3, it was the -1, and the -2. How come I only wrote the -1 one time? Because it had a multiplicity of 2. That means when I graph that point, I need to remember that it is only going to tap that axis. Graphing, estimating for that 1/3, taps the axis, done. W shape. We had 4 points that we used on this graph. Those 4 points were 0, -1/3, switch those. -1/3, 0, -1, 0, -2, 0, and 0, 2. I don't need you to find